let's say we are given a voltage and an impedance, a load impedance, and we are supposed to find complex power, apparent power, average power absorbed, reactive power, power factor, and whether it's leading or lagging. So we have to find all these things. Well, how are we going to do that? Well, this is how I do it. I use the information here. To calculate all these things. Alright, so the first thing we see is that let's get the complex power, apparent power. I always like to just get the complex power. And so I'm going to find the current. So you don't have to find the current, but I like the complex power because everything we need is right there. So V RMS equals Z times I RMS. And so I RMS equals V RMS over Z. So let's change Z to polar. So Z equals 35.5 plus J 9.45. So that is 36.7 angle 14.9. So I RMS equals 110 angle 60 over 36.7 angle 14.9. Now I can either do this by hand or my calculator will do it for me. So 110 angle 60 divided by the answer that I just had. Change that to polar. And I get about 3 angle 45. Okay, so let me see what both of those are. Oh, no, I don't need to do that yet. Okay, so my complex power is V RMS times I RMS conjugate. Now what this means is if I had it in rectangular form, I would change the sign of the imaginary part. So I'll show you both of those things. So we'll just do it, let the calculator do it, and I'll show you how to do it. So let me go back and get what it was in rectangular. In rectangular, it was, our current was 2.11 plus J (2.12). And I want to take VRMS, which was 110 angle 60, times IRMS conjugate, conjugate needs to come first. Three angle 45. And I get 318 plus J85. .4, or in polar, .330 angle 15. Which is what I would have gotten by subtracting these things. Although my number sure doesn't seem right, does it? Oh yeah, it does. Okay, so now, let me get the right units on that. That's VA. Now just to show you, I get the same thing if I get the conjugate. So the conjugate is this with the minus sign, so it would be VRMS 110 angle 60 times 2.11 angle, 2.11 minus J 2.12. And I get the same thing. So that does work. Alright, so there is our complex power. What else are we supposed to find? See, now that we have that, we really kind of have everything, because we're set. Because the complex power has built in it the average real power and the reactive power. So we have average power is the real part, that's 318, and average power is in watts, and our apparent power, we have lots of different ways we can do that. We can take the square root of p squared plus q squared, so p is 318, q is 85.4. We could also just take VRMS times IRMS. So I'll take the square root of p squared plus q squared. Oh, which should be 330. Because I already have that too, because that's what that is. Let's see. What else are we supposed to get? Reactive power, that's Q. .4 VAR. And power factor is the phase angle of the voltage minus the phase angle of the current, which is 60 minus 45, which is 15 degrees, which is positive, so it's lagging. But the power factor is the cosine of that. Cosine of 15 degrees. .966. And I think that's it. So I know that a lot of people prefer to do VRMS, IRMS, cosine phi, and VRMS, IRMS, sine phi, and also I say phi instead of phi. But I just always like getting the complex power because then I have everything I need. So that's that.